Alright, so let's look at another example of a hypothesis test about a proportion with the TI calculator. So when I'm looking through here, I see 777 subjects, and this many of them were dropped or dismissed. Test the claim that most. So most is a majority, more than half. So this is half being a proportion. This is a test about a proportion. That's how I know. Obviously, there's nothing but P's for the parameters down here in the setups, so that gives it away. But if that wasn't there, and it's not going to be there on your test that you do, test 3 that you do for the course. So make sure that you can set this up and understand that that would be the setup, that the proportion P would be the setup that we're using based on the keyword there, most. So greater than 50% is what we're looking for in the alternate hypothesis. So none of these have it. That's a less than. That's the reverse of it. We need the greater than to be in the alternate hypothesis. So B is going to be my choice here. All right, now we're just going to run the test. Once we get the test statistic, the p-value, all that stuff, we're running the test to get that. So to run the test, I'm going to hit Stat, come over to Test. This is a one prop Z test, proportions prop. So this is a test about a proportion. The claim value is, again, most, the claim that most, that's 50%, so 0.5. And then it wants to know what is X and what is N. So X is the smaller of these two numbers, 486, and N is the 777. All right, most would be greater than 50%. So P naught is 0.5. Most would be greater than P naught. So we're going to select that symbol for the right-tailed test. I'm going to select Calculate, and that'll give me the test statistic, is that one right there. To 2 decimal places, that's going to be 6.99. The next number is a 5. So I'd round that up, which means I'll round the whole thing up to 7. 7.00 to 2 places, you could just put 7 and it would accept it as well. Alright, what's the p-value? That's right below the z-value. Now look, it says 1.329. You can't, to 3 places, you can't put 1.329 in there. It's going to say that that's wrong. Alright, I'm going to put it in there just so you can see. If I did 1.329, it's going to say that's not correct. Alright, the reason is a p-value is a probability. A probability has to be between 0 and 1. That's bigger than 1. The problem is, if you look over, there's this e negative 12, which means that decimal point is actually 12 places to the left, which would be 0.1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 before that 1. So this is to 3 decimal places. This is 0. So I'm going to put 0.123 zeros, and that's the p-value. Right? And then what's our conclusion? This p-value is 0. It's virtually impossible for this to be equal to 50%. This is definitely more than 50%. So we are going to reject. Again, the p-value is less than alpha. Alpha is 0.05. 0 is less than that. So we're going to reject. Why? Because the p-value is less than the significance level. So that's why we're going to reject. P-value is less than alpha, we reject. P-value is greater than or equal to alpha, then we fail to reject.